Alright, welcome back to the third of the trigonometric series of the SAT, the top tricks. We're looking at another problem where we see a diagram. And we look at a diagram. We always want to think back, what are the options here? Well, triangles, and if they're connected, they're probably going to be similar. But let's take a look at the information we're given. In this problem, we're given a few bits of information here. So they're saying that, for example, they say that they give this language, this mathematical language, they're saying that this, of course, they're saying that line AE is parallel to line CD. So we draw the parallels in there. And that's one thing they give us. Secondly, on the problem, they also say, hey, AD, segment AD, intersects segment CE, epi. Which means these two triangles are linked, and if they're linked, that means that these two are vertical angles. And if they're linked, they're similar triangles, like so. And we can prove that, obviously, by doing a little bit use of the parallel. Because if these two are parallel, the alternate interior angles here must be equal. And it also applies to the other set of alternate interior angles, like so. So now we can apply the numbers here. They give us a set of numbers. They say that, for example, this is 10, that's 20, and they're saying this is 16. And in a common SAT problem, they'll say, hey, what's the length of segment CE? So they'll say there, they want to know the segment length. You can see that? Yeah. That's what we're hunting for here. So what's the strategy? We've already done it as we've gone along. We highlight on the givens, and we highlight them on the figure. That's really important. Here, and then how do I show this? Well, I show that these are vertical angles, and now I have my structure. Well, to find CE, we need to have this component, which we have of CE. This is the BE part. And we need also the CB part. So let's call this a familiar letter. Let's call it X. And we have similar triangles, which we have by AA, or AAAA, AAA, pardon me. We can make a equation. So we'll make the equation between the triangles. And so we're going to go, because X is on the small triangle, let's see if we have room here. We're going to do our small, so we're going to go small triangle over big triangle, okay? And here's what we're going to do. So it's going to be, in this case, the small value, we're going to say, let's use 10. And notice 10 is the value between the vertical angle and the angle I mark with 3 oval lines here. So I got to do the same thing on this big triangle. I find this one and that one. That's a 20. Okay. And I know this ratio is going to hold true for all similar triangles. They're going to have the same ratio, between these similar triangles. They'll have a common ratio. So let's try the X now. And the X, well, that's between the vertical angle and the angle I mark with 2 oval lines. Oh, that's 16 over here. And so we set up the equation. Let's multiply both sides by 16. Here, 16 there. We'll cancel that and we'll rewrite it down here. So we know that 16 times 10 over 20 equals X. And we'll cancel out. We'll cancel that. Look at that. We'll get a 2. And then we go cancel the 16 out with the 2. And we get an 8. X. And so just to recap there, our answer is 8. Oh, but wait, that's not all we wanted. We want the value of CE. So CE is going to be the value of X, which is 8. So it's going to be 8 plus 16. And our value is going to be 24 was the true answer they wanted. So even after all that work, you could still get it wrong. This is now calculator-free trig, and we want to sum up the tricks, follow the givens, draw the givens, set up your equations. Make sure your ratio is consistent between small triangle to big triangle if what you're looking for is on the small triangle in this case. And finally, check what the problem asks you to do. You weren't done at 8. You had to add the 8 plus the 16. And that's the third trick of the top tricks of SAT for the trigonometry. Until next time.